Hello and welcome guys. In the last video, we introduced various types of operators in Python and then looked at some of arithmetic, bitwise, and assignment operators with simple mathematical examples. In this video, we will build on that knowledge and learn how comparison, logical, identity, and membership operators are used with more practical examples. I highly encourage you to code alongside me, pause and play the video as many times as you need while doing so. Soon we will be knowledgeable enough to begin working on small projects, so having a good understanding of the basics at this stage will really set you apart when you step into more complex things. With that, let's take a look at comparison operators first. Comparison operators are used to compare two different values. So basically, compare the values to the right with the values to the left and decide the relation among them. Therefore, they are also called relational operators. It's super easy to understand if we take two example variables to work with. So let's start, let's take two simple numbers, a equals to 4, let's say, and b equals 2. And then the simple comparison would be a equal b. That is to check whether a and b are equal values. Um, but if we just do this and run it, it's not going to give us any output here. So let's wrap that around a print statement and say a is equal to b, and then we're gonna spit out whether it's true or not. And when, let's say if we run this, we're gonna see that a equals to b is false in this case because there are two different values. These are just integers. We can try with floating point numbers and see what we get. If we make this 4.0 as well, now we should get a true output. Let's also try with strings. I'm going to write a string and assign that to A and assign that to B as well. And when we do comparison, they are both same or equal, so it's going to spit out true. Obviously, Python is case sensitive, so if we do one of those S as a capital letter, it's going to give out false. Let's see what we get with a lower function, using lower function on this. And it would be interesting to see what we get here. And in this case, we get true. String and string lowered to a lowercase characters. When we compare them, they are true, meaning they are same or equal. We're not just limited with numbers and strings. We can also use lists or different lists to compare. So let's say I'm declaring two different variables or list data types, and when I want to compare these two, we would get true because they are both of same value. Now, if I want to edit one of these and add a new member, let's say goat, for example, and when we run this, they are not equal, so it would give out false. As you saw here, whether we put single quote or double quote, it really doesn't matter. We could do single quote word goat here and make a comparison, make a comparison here, and we still get it true as an output. So that was equal to comparison, whether the left side is equal to the right side. Um, Now let's also take a look at not equal to. And when we do not equal to, we just replace with the exclamation sign. And obviously it was true earlier, so this not equal to would give us a false. Let's go back with numerical values. If they are same, not equal to will give us false. If they are different, like in this case, let's say 0.1, 4.1 and 4 are not equal, so it would give us true output. Most of the times when we program, whether in Python or any other language, the programmers or our developers are usually interested in seeing whether some value has reached a threshold. So is it really greater than some number or greater than equal to some number? So in that case, we could use this comparison. So let's go back to 2. And if we are saying if A, let's say A is greater than B, and for that we have to do greater than comparator, comparison operator. So here A is 4, B is 2, and we're comparing whether A is greater than B. And if we run that, we get true value. If we have both 4 and if when we use greater than or equal to B, since they are both equal, it would give out true. Sometimes it's a little bit trickier to work with negative numbers, but we have to know how the program behaves. And so in this case, A is -4, B is 4. If we're checking whether A is greater than or equal to B, since here A is less than B, we get false output. We can also try this with without two variables. So let's say we're just checking is A greater than 0, and for in this case greater than, we're just checking greater than 0, and in this case it would be false. If it was a positive number, it would be true. Um, one might say, hey, we could use a bool operator or bool function like this with A as an input and see if A is a positive number or not. In case we run this, because A has a value other than 0, it's giving us true. But if we change this to -4, what do you think would happen here? Well, A is still any value other than 0, and when we do bool A, it will return true. So when we run this, we would still get true, but this is not the desired outcome that we wanted to see. What's happening here is basically when we do bool A, that parameter is looking at whether A is a non-zero variable or not. We need to be careful with stuff like this because in terms of program syntax and program logic, this is working as expected, but this would be a bug that would be hard to find and fix later. So the lesson learned here is that we should try to keep our program simple as much as possible. So those were quick examples to cover most or all of the comparison operators in Python. Next, we'll um, go with examples and logical operators. Logical operators are the and, or and not operators. To explain logical operators, I think it is better to use truth table, and from that we can visualize or know when certain input will result in true values. So if you look at these truth tables on your screen, if the input is A and the input A has value true, not true would be false. Similarly, if input A is false, not A would be true. So that's the truth table for logical not. For or and we need two inputs, A and B, and whether they are true or false, depending on whether A and B are true or false. Or logical or would give us false only when both are false. So A is false or B is false, then the output is false. In other words, as long as at least one of those the inputs are true, logical OR would result in a true value. On the other side, the inputs are same for A and B on the truth table for AND operator. In this case, as long as both A and B are true, the output would be true. And as long as at least one of those inputs A and B have a false value, the output would be false in this case. With that explanation, let's see how we can implement or visualize that in Python programming. So I'm going to replace the values here for A and B with true and false. And then I need to show print statements. So let's say something like this. So I have two inputs A and B, both are true in this case. In the first instance, I want to print not A. In the second instance, I want to print A or B, and then A and B on the third print. When I run this, not A, which is not true, would be a false output. A or B, as long as at least one of them are true, the output would be true. And for A and B, as long as both are true, it would spit out true. So you can see that comment here. Output for this is false only when both A and B are false. That's for the OR statement. And for the AND statement, output will be true only when both A and B are true, similar to what we saw earlier in the based on the truth table. So I hope that gave you some understanding on truth table as well as how um, not, or, and logical operators work in Python. Let's twist this a little bit and try this similar statement with something other than Boolean values. So let's go back to integer numbers. I want to try 4 and 10, and then I want to do print A is less than 5 and B is less than or equal to 10. Just space for better readability. When I run this, it gives us true. So what's happening here is we are implementing two different checks here and then ending them with this. Um, sorry. So this is one output. This is one output. We are using those output as an input to this to this logical AND. So this is comparison, and then a logical operator in combination here. And when we do the print, it calculates all of that and just gives out one value which happens to be true here. So why is it true here? If we look at the values, A is assigned 4, B is assigned 10. A is less than 5 is true because A is less than A has a value of 4. B is less than or equal to 10 is also true because B is equal to 10. So true and true, since both input are true, the logical AND would result in true in this case. We could easily change this and see if B is less than 10 and see the output. In this case, it would be false. So what you're seeing here is a typical example of how logical operators can be used to combine conditional and or comparison statements when we do programming. Next, we will learn about identity operators. In Python, operators is and is not are the identity operators. Identity operators are used to check if two values or variables are located on the same part of the memory. This is different from comparison operator because in comparison operator, we are checking if two values or variables are equal. But with identity operators, we are checking if the two values or variables are stored in the same location. not if they are equal. In other words, identity operators are used to compare the objects, not if they are equal, but if they are the same objects with the same memory location. Let's see with some examples. I'll stick with these numbers. I'm just going to check because we want to see identity operators. Let's go back and edit that and make both A and B same value. Um, I want a new print statement instead of this, something like this. So print ID, we're checking two IDs, one for A, one for B. In this print statement, in the next line, we are going to output A is B uh, operator, our identity operator, and whether A is not B. So in this case, both are 4. And here we are checking are they equal as well as identical. And here we're checking the opposite, whether they're not identical. So when we run this, we get 3 lines. Interestingly, in the first one, you see ID of A and the ID or address value of B are both exactly the same. So in this case, A and B are equal, and then their address location are also same. So in this when we do the print, A is B, it's giving us true because they are equal and identical or at the same location. And A is not B would be false because of the same reasons. We can try this with floats and see what we get. Um, when we run this, we get similar output. Both these IDs are same, so this is true and this is false. If we make two different values, the IDs would be different, and therefore this is false and this is true. So let's try this with strings. So I'm going to erase that ASD. Let's say a simple string, another ASD. When I run, well, with strings as well, we get same IDs, and therefore A is B, or they are identical, and A is not B is false. But since Python is case sensitive, we can swap with small letter a and see what happens. We get different IDs, so this is false, and then therefore A is not B, or that statement is true. Let's try this with two different lists. So for this, I'll import list instead of string variables A and B. Here I have two 4, 8, 12, and string goals as um, items in both list A and B. And rest of my print statements are pretty much the same. Let's see what we get. Well, in case of list, the IDs are different. So and they are not equal. They are although they are equal, they are not identical because they are stored in different locations. It is because the interpreter locates them separately in memory in case of list, although they are equal values or have a similar or same exactly same items in this case. So I think that bit of explanation will help you understand how we can use identity operators with different types of value or data types. Next up, I want to talk about membership operators. In Python, membership operators in and not in. There's a typo here. This should be in and not in are the membership operators. They are used to test whether a value or variable is presented or present in a sequence, such as a string, list, tuple, set, or a dictionary. Again, let's start with some simple integer numbers and build on that with more complex examples. Or actually, I'm gonna keep A, get rid of B because that A has everything that I need to explain this. Um, so let's say I want to print something like if there's element 4 in A. So all this is doing is if checking if this element 4 is an item in list A. And when we run this, because it is true, it's giving out a true value. I like this example because we have different types of data types within this list here. So let's say I'm checking for goal or word goal in this list. And in this case, it is. So it is also giving a true value. Um, we could also itemize this. And let's say I'm looking for word go in A, which is false. But if I'm to look into the index, using index, if I'm going to go to index 3 within the list, so A3 basically, if you saw my last video, what it is doing is it's indexing third um, position number 3 in this list. So 0, 1, 2, 3. So this is what we are looking for. And A3 has a value of goal, and we are seeing we're interested to see if string go appears in goal, basically. When we run this, we still get true. We don't have a floating point number in our list, but we can try 12.1 in A. And when we run, there's no value 12.1 in any of the lists within A, in any of the items within the list A. So it is giving out false. Same would be the case for non-existing integer value. So let's say we're checking for 9 in this list. It is not there, so it's giving us false. But now let's take this to a little bit more complicated example. So in this case, I want to keep that and or that with another membership operation here. I want to see if 5 is in if element 5 is in the list A. So here I'm checking whether 9 is in A or 5 is in A. And since neither of those are present in A, the OR statement is basically giving us a false because both input on the left and right of OR are giving off false. We could do this with and see what we get. It's still false for the similar reasons that I explained just now. Uh, and will give us true, as I explained just earlier in this video, and would give us true if both the inputs are true. If this was true and this was true. So let's try that. So here I would make 4 and then see 8 in A, and that would be true. So instead of A, let's bring back goal in A. So there's 4 in list A and goal in list A, and gives out true. As Python is case sensitive, capital G would be false. I also want to go to another example, a little bit complicated. So let's use a dictionary instead of a list here. I want to bring back this phonetic dictionary that I used in my previous tutorial videos. In this, I have key value pairs. So this is an item, this is another item, and there's 3 different items here. Each item has key and value pair. So key value, key value, key value. That's how dictionaries work. Um, Now in the print statement, I want to see if A is in the phonetic dictionary. Does A exist in the dictionary? And it's saying yes, it does. But if we do small a, it's case sensitive, so it's going to give us false. We could do combinations. Um, let's see something that's not there. So capital D isn't there, so it's going to give us false. One thing we have to note is when we work with membership operation with dictionaries, it is not looking for values, but it's only looking for the keys in the dictionaries. So if we do try to source for alpha in this phonetic dictionary, although dictionary this phonetic dictionary contains alpha, it's only a value for that key A. But when we do alpha in phonetics, it's looking for the keys, not the values for any of the keys. And therefore, in this case, it would give us a false. So that's it for this video, guys. Just to recap, in this video, we talked about different types of operators that we didn't talk about in the last video, especially comparison operator, logical operator, identity operator, and membership operators. I hope you liked the video. Please don't forget to like, share, subscribe, add your comments, and also hit that bell button so that you get timely notifications. Until next video, see you.